Hello, my name is RAHMOUNE Abdelbasset. I'm a PhD student in material physics at University of Ouargla. My presentation titled A Simple Method for Large Area Graphene Transfer Using an Office Laminator. Here we present a method for transferring large area graphene using commercially available prefabricated polyvinyl alcohol foils used for hydrographics printing, commercial tabletop hot roll office laminator, and water. PVA lamination transfer of graphene were performed according to the procedure illustrated in this figure. Copper foils with as-ground graphene were placed overnight in deionized water at room temperature to oxidatively decouple the graphene from the catalyst surface. After drying the copper substrate, the PVA film was laminated on top of the graphene copper foil using a commercial hot roll office laminator. The PVA film was then mechanically delaminated from the copper surface, lifting the graphene along with it. The graphene layer is now ready to be transported and eventually deposited on an arbitrary substrate. This was done by laminating the PVA graphene film onto a target substrate under the same lamination conditions and finally removing the PVA in room temperature deionized water overnight. Optical microscopy and terahertz TDS measurements both confirm that a continuous layer of electrically conductive graphene was transferred over the entire sample area. The terahertz TDS map shows an average sheet conductivity of approximately 0.5 millisiemens and is relatively homogeneous across the area. Optical microscopy, Raman spectroscopy, and measurement of the amount of copper lost following each growth and transfer cycle on the same copper foil demonstrates the usability of copper foils for repeated graphene growth and transport. The comparison of PVA lamination transfer with standard chemical etching and bubbling transfer using Raman spectroscopy and terahertz TDS measurements demonstrate that etching and bubbling transfer have a greater determinal impact on graphene properties as compared to PVA lamination transfer. In this work, it has been demonstrated how commercially available PVA films, widely used for the hydrographic transfer of printed images, can be employed to mechanically transfer graphene from growth substrates to target substrates using a low-cost office laminator. The present work demonstrates that PVA lamination is greener, lower-cost, highly scalable, and more convenient process for graphene growers and end users than existing techniques, and has considerable potential for more development and use in research and industry. Thank you for your attention.